Hello and welcome to our video class notes on atomic number and mass number, two very important numbers for us to understand in Chemistry 1. This is our class notes over 3B4. As we get started taking and looking at atomic number and mass number, it's important for us to recall that there are three subatomic particles found in an atom. And atomic number and mass number tell us about these types of subatomic particles. Two of the particles are found in the nucleus. Protons are positive particles in the nucleus, very close to the same mass or size as a neutron. So the protons and neutrons are both in the nucleus. Neutrons are a neutral particle. Neutrons are abbreviated with an N and a 0 because they are neutral. Protons are abbreviated with a P for proton and a positive sign. Any particles found in the nucleus, the protons and the neutrons, are called nucleons. Nucleons are the name for the subatomic particles found in the nucleus. The nucleons, the protons and the neutrons, are not directly involved in chemical reactions. It's the third particle, electrons, which are involved in chemical reactions. Electrons are a negative particle found orbiting outside the nucleus in three-dimensional orbits. Electrons are either shared in chemical reactions, that's called a covalent bond. They can be transferred, where one atom steals an electron from another atom. In either case, electrons are involved in chemical reactions. A third type of bond is metallic bond, where all the atoms are sharing all the electrons that are surrounding them. So these are the three subatomic particles. The atomic number tells us exactly how many of one of these particles are in the nucleus, and that would be the proton. Atomic numbers reveal the number of protons in the nucleus. For an atom which has not yet reacted chemically, or for an atom that has not gained or lost electrons is maybe a better way of saying that. If you haven't gained or lost electrons, you are called a neutral atom. And in this case, the number of protons would equal the number of electrons for neutral or normal atoms. Neutral means it doesn't have a charge. The only way it couldn't have a charge is if the number of positive protons are balanced by the number of negative electrons. Atoms that have exchanged electrons in a chemical bond called an ionic bond form charged atoms that we call ions. If there are more electrons in the atom than there are protons in the nucleus, the atom would have a negative charge overall. If there's more protons in the nucleus than there are electrons orbiting the nucleus, if you have more positives than negatives, the atom would be positive. Positive atoms we call cations. Atoms that have gained electrons we call anions, as it reminds us right down here. Atoms that gain electrons, gain has the word N in it, negative has the word N in it. Negative ions are called anions. That's the one with the N right in the middle. Atoms that have lost electrons, the word lost has a positive sign at the end of it. If you look at the T, it sort of looks like a positive sign. Atoms that have lost electrons are positive ions, and we call those cations. Cations has the T or positive sign right in the middle. Another way to remember that cations are the positive ion is cats have paws. So cations are positive. So when would the number of electrons equal the atomic number of protons? That would be for a neutral or normal atom. Atomic numbers are abbreviated with the letter Z. Now, protons are an extremely important number. The number of protons determines the identity of the atom. As was discovered by the scientist Moseley. Moseley realized that if you knew how many protons an atom had, you knew what atom that element or what element that atom belonged to, and you also could predict the chemical properties of the atom. Why did Moseley say that that would only work for protons? Because if the number of protons equals the number of electrons for a neutral or normal atom, then why couldn't electrons be used to tell who the atom is? And that's once again because electrons can be transferred from one atom to another in a chemical reaction. When a chemical reaction occurs, the atoms you start with are the same as the atoms you end with. The identity of atoms are not changed in a chemical reaction. That's called the law of conservation of matter or mass. All the atoms that go in the reaction are the same atoms that come out in the reaction. The mass that goes into a chemical reaction equals the mass that comes out in a chemical reaction. That is not the case with nuclear reactions. Nuclear reactions involve changes in the numbers of protons or neutrons in a nucleus. If an atom gains protons in a nuclear reaction, or if a nucleus breaks apart and loses some of its protons and neutrons, the atoms you end up with are different than the atoms you start with. So the atomic number is an important number. It's represented by the letter Z, and it reveals what element an atom belongs to. Here we have a periodic table of elements. You'll need your periodic table of elements handy in Unit 3B. As a reminder, your periodic table of elements is in the class information section on Google Classroom. On this particular periodic table of elements, the atomic number is listed in the upper left-hand corner of these boxes. It is always a whole number because an atom cannot have part of a proton. And that number tells you the number of protons an atom has to qualify as a particular element. The atomic number can sometimes be in the upper right-hand corner. Sometimes it can be in the lower left, lower right, or underneath the element or symbol. In this particular one, it is just placed in the upper left-hand corner. Any atom with a 1 for an atomic number belongs to hydrogen. So if you have 1 proton, you're hydrogen. Neutral hydrogens would also have 1 electron. If you have 2 protons, you qualify as a helium atom. You belong to the element helium. Carbons have 6 protons. Phosphoruses have 15. Aluminum has 13. How about silver? Silver, symbol Ag for argentum, the old name for silver, is any atom with 47 protons. Silver, before it reacts, would also have 47 electrons, but silver commonly loses 1 electron in a chemical reaction, which would leave it positive, because if you lose a negative thing in a chemical reaction, you're left positive. Lost has a positive sign on it. So if you lost an electron in a chemical reaction, you would now have 46. But you're still silver. It doesn't change silver into palladium in a chemical reaction. That could only happen in a nuclear reaction. The only way silver could become palladium is if a proton broke off the nucleus. What are these decimal numbers in each of these boxes? We're going to learn what these decimal numbers are in Unit 3B. But what this is called the atomic mass. The atomic mass is the mass of all the naturally occurring isotopes of an element. We will be discussing what isotopes are. What isotopes are different forms of a given element. So we're looking down here on this word right here, isotopes, atoms of the same element that have different numbers of neutrons. Again, what makes an atom a particular element? It's the number of protons, not the number of neutrons. So isotopes have to have the same atomic number, but isotopes have different mass numbers, and we'll talk about what a mass number is here briefly in a moment. Here are isotopes of carbon. Isotopes have the same number of protons, but they can have different numbers of neutrons in an atom. Atoms that have different numbers of neutrons doesn't affect who the atom is. So carbon-12 are isotopes of carbon. It's an isotope of carbon that has 6 protons because all carbon atoms have to have 6 protons, as it says right here. The atomic number of all carbon atoms is 6. But this particular carbon atom has 6 neutrons in the nucleus. 6 and 6 is 12. This carbon atom right here, called carbon-13, has to have 6 protons for it to be called carbon, symbolized by the letter C. But this one has 7 neutrons. It didn't change who it was. Carbon-14 is listed right here. Carbon-14 has 6 protons, and this one has 8 neutrons in the atom. They all have 6 protons. They are all carbon. But carbon is allowed to have different numbers of neutrons in the atom. Isotopes are atoms of the same element. Isotopes are atoms of the same element that vary in number of neutrons. In other words, they have the same atomic number but different mass number. What do we mean by the word mass number? Mass number is the number of protons plus the number of neutrons. In other words, mass number tells us how many nucleons an atom has. Nucleons are the particles in the nucleus. So the mass number of this atom is 12. 6 protons plus 6 neutrons is 12. The mass number of this carbon atom is 13. 6 protons and 7 neutrons is 13. The mass number of this carbon atom is 14. 6 protons and 8 neutrons gives a mass number of 14. Mass number is abbreviated with the letter Z. Or A, I'm sorry. Mass number is abbreviated with the letter A. Atomic number, on the other hand, again, is the number of protons, and it's abbreviated with the letter Z. Atomic number is abbreviated with the letter Z. We mentioned the decimal number on the periodic table of elements. Well, carbon has 3 different types of atoms that it commonly can be found as. By and large, almost all carbon atoms are carbon-12, 6 protons, 6 neutrons. Some carbon atoms have 13 things in the nucleus. Other carbon atoms still have 14. That decimal number is the average mass of naturally occurring carbon. So if you dump out a pile of carbon, 90 some odd percent of those are carbon-12. So most carbons have a mass of 12. Some have a 13, fewer still have a 14. But the average mass of carbon atoms is 12.01. Why is it so close to 12? Because virtually a huge percentage of the carbon atoms are indeed carbon-12. So what have we talked about so far? We've talked about atomic number, a very important number. It's the number of protons in the nucleus. It identifies who the atom is, and for neutral or normal atoms, it also tells you the number of electrons. Mass number, abbreviated by the letter A, tells you the number of nucleons. Nucleons are the protons and neutrons in the nucleus. Mass number relates to a particular isotope of the atom. Isotopes are the different forms of the atom. Over here we wrote C with the 12 after it, C-13, C-14. That's called hyphen notation. Hyphen notation shows the symbol or name of an element with a hyphen followed by the mass number. Here they use the symbol carbon-12, carbon-13, carbon-14. It just gives you the mass numbers. It doesn't tell you the atomic number because when you use hyphen notation, it's an assumption that you have a periodic table around to look up the atomic number. Now, the word nuclide is under each of these, nuclide or nuclide. A nuclide is a distinct kind of atom characterized by having a certain number of protons and neutrons. So the carbon-12 isotope is a nuclide with 6 protons and 6 neutrons. The carbon-13 isotope is a nuclide characterized by 6 protons, 7 neutrons. Carbon-14 is the nuclide characterized by 6 protons, 8 neutrons. So these are the isotopes of carbon. Each of the isotopes is a specific nuclide. The way I look at it is nuclides are sort of like identical twins. They have to have identical things in the nucleus. Isotopes are like fraternal twins. They're very similar, but they can be a little different. What makes an isotope a fraternal twin is the number of protons. They all have that in common. What makes them a little different is their number.